So, hello student. So, we are at last lecture on anaerodization, transformation, biological transformation. So, in this lecture I will talk about type of biogas digester. So, in the previous lecture I talked about different stages of anaerodization process, different factor affecting anaerodization process. In the previous lecture I talked about how beneficial is the pre-treatment process for various type of lignocellulose biomasses, and also I talked about co-digestion or co-digestion of different by mixing of different substrate together to maintain the proper carbon to nitrogen ratio. Now once you understand the proper substrate mix hydrolysis process, now we will come to that acid phase and methane phases or the last stages, and these last stages will be inside the one particular reactor called biogas reactor. So, here in this lecture we will talk about the different type of biogas reactor and what are the different benefits of having the different biogas reactors. So, what is biogas reactor? The biogas digester is a closed container in which segregation and feeding of the organic substance take place, or majorly the acetogenesis and metheogenesis will be the inside this biogas reactor. So, in this digester the biodegradation of substrate take place under the anaerobic condition and in the presence of metheogenesis bacteria producing a methane rich biogas. The generated biogas can be further used for cooking and electricity generation, that is obviously that is the benefit of biogas production. The fully stabilized digested slurry or digestate can be used as a fertilizer or soil conditioner depending upon its characteristic. So, that is also the benefit what waste product we are getting from the biogas reactors. So, there are basically three types of biogas digesters are available. Fixed dome, that normally we called as a Chinese type of reactor, floating drum type reactor, that is Indian type, and the back type of biogas reactor, that is Taiwanese type. I will show you the different photographs also where these kind of reactors are installed and already in the working conditions. And these digesters can be further divided. Again, I think this is the different type of biogas reactor and further divided into the either in the continuous mode, the material is added continuously and biogas production is uninterrupted. So, here you can say is a continuous mode or you can say fed batch process. Continuous means continuously or 24 hour the substrate is adding into the biogas reactor. It is also possible like our country, the waste collection once in a day, okay, once in a day in morning we are collecting the waste, and every morning every day we are feeding the reactor continuously. So, I think you can say is a continuous reactor or we can say fed batch reactor, means every day we are feeding the reactor. Another is the batch mode. A material is loaded once in single operation and left until biogas production ceased. So, the first type of reactor is a fixed dome type of reactor. So, this is the dome, the top area. So, the first type of reactor is a fixed dome type of reactor. So, this is the dome is fixed and this is the reactor. Okay. So, dome is fixed here. So, the fixed dome consists of a airtight container or fermentation chamber. This could be constructed by brick, stone or concrete. So, this is the inlet. So, by inlet and this is the outlet. So, onto the top you will find this tank and this is the outlet tank, and this is the fixed one dome, and from the top one pipe will be insert into the digestate to get the biogas. The sealing is achieved by building up several type of motor on the digested inner surface. The design of fixed dome type of biogas digester originated in China in 1936. Is one of the oldest technique, you can say that for biogas production. And the first fixed dome design in India was named as Janta model, which could not become successful because of construction problem. The major problem was gas leakage, because this sealing should be there properly, okay, onto the dome, and that become obsolete. And then came its successor, like this is the very popular model, Deenbandhu model, with improved design and consumed less building material. So, you remember these 2 points. The first model was Janta model, was similarly to the fixed dome, and the modified one is Deenbandhu model. And typical feedstock for this digester is animal manure, night soil and agriculture waste. So, mostly I think this kind of reactor had been started long before, especially for the animal manure like cow dung. In India normally this Deenbandhu model we used to talk gobar gas plant. So, gobar gas, gobar in Hindi we called as a cow dung. So, cow dung based, or sometimes we will add night soil. That was also very popular, by or otherwise that was a mixing of night soil with cow dung, that was, and some agriculture waste. So, is a schematic diagram of Janta model. So, this Janta model you see that is a same of Chinese model, fixed dome model, and now here is a Deenbandhu model. Okay, this is the Deenbandhu model. So, only the changes was the construction was easy, and here you can see that here the outlet is different. Now, here you see the outlet chamber. So, now suppose some kind of problem in the reactor, suppose somewhere leakage is there. Suppose in this dome if you find someday some leakage of gas, in this case if suppose some leakage are there, you can't do anything. Now, once a leakage problem will start, it is very difficult to reduce that leakage in the Janta model. But in case of Deenbandhu model, here even one particular person can enter. So, that outlet is so big, so big, so that any person also can go inside and can check the leakage, and if some leakage is found, they can remove that particular leakage. That was the benefit of the Deenbandhu model. So, now that is why, because Janta model become obsolete, now nowhere you will find, and Deenbandhu model, because the other advantages of that, underground digestion chamber providing good insulation. So, you see here this entire area, now this is the earth plinth level, you see here. So, see the entire construction is underground. So, because of that it become good insulation, because normally it believed that this anovidization process is highly affected by the local conditions, and like India kind of country where not only the temperature, but different climatic condition you will find in the entire year. Like I talked about in the composting process also is getting affected by the different climatic conditions. So, similarly this anovidization is also highly affected compared to the aerobic degradation process like composting. So, this entire unit will be underground, so that it will not have create any problem for the local conditions. Improve stability due to lesser variation of temperature underground, more crack proof and lesser quantity of building material requirement. That was the benefit of Deenbandhu model. So, you can see here the same one. So, this could be a inlet, this is the dome. So, one pipe is coming out for the gas, and this is the outlet tank. Now, this is the another one in Kenya. So, many developing countries they adopted this model and installed in the various locations, but mostly this kind of digester has been installed in the rural areas, and substrate was majorly the animal manures or animal waste, along with that some agriculture residues. So, what are the advantages of that? Low initial cost, long useful lifespan. This is also very important. It can work for more than 20 years, low construction cost and required less space. If you talk about 1 meter cube of biogas reactor, which can handle 5 kg or 10 kg of waste, even 5 kg of waste in a day, will require maybe 5,000 rupees was enough for the construction purpose. And even the operation also is not that difficult. Any farmer was not knowing the proper operation, but the operation was simply just feed it, whatever outlet is coming, that you put it into the in the agriculture area, and whatever gas is coming, that you use for the cooking purpose. But only there are some disadvantage, that masonry gas holder required special sealants, because see, along with the biogas production there will be some water vapors also are getting produced. So, when you are putting the pipe, so in the pipe the moisture also will come out, and because of that the blockage of gases could be possible. So, high technical skills for gas tight construction, gas leaks occurs quite frequently. I think this gas leakage mostly is because of what I said it, that because moisture is coming out, because there will not be any evaporation, because it is inside the pipe. So, that somewhere the water will accumulate in one particular location, because of that the flow of gas will be reduced. And because of that the lot of gas, rather than coming to the gas pipe, it will come out into the outlet. So, you will see the lot of air bubbles you can find in the outlet tank. Fluctuating gas pressure, excavation can be difficult and expensive in the bedrocks. So, because is a entire reactor is a underground one, so you will be required excavation, and if there is a bedrock, so in those cases the excavation is not easy. Now, the next reactor is a floating drum type of reactor or Indian kind of reactor. So, in India the first time Jashu Bhai Patel, I think you need not to remember that, but it's a long back, this person in year 1956 first designed the floating drum biogas plant, and that popularly called as a Gobar gas plant. Okay, that was floating type, and you remember that in the 1956 that person had thought about, because when I was reading about something about that particular person, because in the both the cases, like whether you take Janta model, Dinbandhu model, was installed in the large number, but the problem was leakage was always in the both the cases, because in the floating drum biogas reactor the gas has to be come out wherever it will find the space. So, and because in entire the dome was fixed, and what this person have thought of, why not we would do not put this dome as in fix, and if you float this dome, so obviously the gas will come out in from the only one location. So, likewise rather than leakage, you need not to have make this dome by the any civil construction material, because it has to be float. So, you can go of metal of construction of this kind of dome, or we can make some plastic also we can put it, so that we can reduce the leakage of the gas. So, floating drum pipe consists of in a underground digester, maybe cylindrical or dome shaped, and a moving gas holder. So, that was his idea. This is the fixed one, okay, and this dome is a gas holder, and once the gas production will be there, this gas will stored into the gas holder, and if the gas concentration will increase, this dome will go upward. The gas holder floats either directly on the fermentation slurry or in a water jacket on its own, because in this one there will be a water, so that there will not be any leakage. So, there could be a water jacket, or directly into the waste it can enter. The gas is collected in the gas drum, which rises or move down according to the amount of gas stored, and the gas drum is prevented from tilting by a guiding frame, because there will be some guiding frame will be required, so that it will be rise in the upward properly. When the biogas is produced, the drum moves up, and when it is consumed, the drum goes down. So, in 1962, the khadi and village industry like KVIC of Bombay, India began using the Patel model, the same Patel model biogas plant in the plant program in 1962, and since then there have been a number of improvement in the design. The reactor fed semi continuously through an inlet pipe and displaced an equal amount of slurry through an outlet pipe. So, when the reactor has a high height to diameter ratio, a central baffle is induced to prevent the short circuiting. So, that was one very important improvement has been done in the reactor, that Patel model. So, earlier the Patel model was only the one particular unit, but the improvement was there was one baffle, central baffle has been added. So, now how the flow of waste slurry will be like this, and the idea was that half of the area will be for the acid phase, and the other half will be for the methane phase. That was the thought, but is not completely separated one, but the idea was that the entire material will be inside the reactor, or the residence time could be increased, and so that more methane production could be possible. So, there was a inlet pipe in the same reactor, outlet pipe, and one partition wall or central baffle was added. So, this was the one floating drum type. So, you see here this is a metal constructed. So, this is the civil construction material for the lower side of the reactor, and this floating drum of metal and the gas collection pipe. So, this is one of the unit like 35 meter cube floating drum type of reactor. So, you can see this is also metal unit. Now, what are the advantages? Easy operation, constant gas pressure, and stored gas volume can be seen by position of the drum. This is one very important benefit. Like in the fixed dome, we are not able to see how much gas has been stored in the reactor, but in the floating drum we know that by seeing that how much the gas has been produced. So, based on the availability gas, we can use for the cooking purpose or energy production of that. So, every day we can see easily how much gas has been stored into the that floating dome. And the disadvantage that steel drum is relatively expensive and its maintenance cost is high. Obviously, we need to use steel drum, or otherwise if you use other metal, the corrosion will be the major problem, and painting should be carried out on regularly to prevent rusting, and even for the steel it will be required time to time painting. and lifespan of the drum is short, up to 15 years, in tropical coastal region about 5 years. Gas holder can get stuck in the resulting floating scum if organic substrate is fibrous, but again is depend upon the special type of substrate. If you maintain the proper substrate, this kind of disadvantage can't be possible. So, next is bag or balloon type of digester. So, the bag digester type comprise of a long cylinder of either PVC or polyvinyl chloride or a material known as red mud plastic, that is developed in 1974 from the residue of bauxite smelted in aluminum production plant. That was one particular industry. They started this kind of digester. The idea was that this is the balloon. So, here the waste will enter into the balloon and degradation will be followed inside the balloon, and the gas will produce, and there will be one outlet. From that, time to time the outlet will get collect. Also, this is only a simple digester. So, incorporated in the bag are inlet and outlet pipes for the feedstock and slurry and gas outlet pipe. The feedstock inlet pipe is situated so that pressure in the bag is kept below 40 centimeter of water pressure. So, that is the important for inlet pipe. Gas produced in stored in the bag under a flexible membrane. A complete 50 meter cube volume digester weight just 270 kg and can be installed in a shallow trench. Is a lightweight material, and we can change the location also time to time very easily. So, this is the, you can see here. So, slurry inlet. So, this is the floor level, this is the floor level. So, this is the slurry inlet and this is slurry outlet. Now, this is the degradation process. So, this much area is available, means half of the balloon for the storage of biogas, which we can easily collect from the gas outlet. Feedstock is fed into a bag semi continuously with the feed displacing an equal amount of slurry removed from the outlet. If the red mud plastic or PVC is unobtainable, the design can also be constructed from concrete with a flexible gas collecting membrane situated at the top of the container, but that is also difficult. So, disadvantage of that, like fabrication material if damaged are difficult to repair, remote or rural area lack access to repair material facility. So, this you can see the balloons. So, half is underground, that is for fermentation process, and half is onto the top of the surface. So, and these are the inlet pipes, inlet, and the outlet is directly going to the field. So, you can see that these kind of balloon digester can be easily, we can change the location. So, the transport bags are attached to the system and filled with the gas. These are 4 kg filled pillows with biogas. So, it is a 4 kg. So, anyone can easily transport. You can also see here, these are the gas bags. These pillows are stored in the houses in this way. You can see here the 4 kg pillows can provided to 4 hours of continuous operation of a gas burner for heating or cooking. So, the production is somewhere else, but the same bags you can take it out and get it to the different houses for the cooking purpose. This is one balloon type biogas digester in Ahmedabad, Gujarat. but this majorly for the cattle manure. Okay. This is in the Costa Rica. Type of digesters according to process steps of anaerobic digestion. So, there could be a single stage digester. So, all the stages of anaerobic digestion process occur inside a single tank or complete among themselves. So, only one reactor for hydrolysis, acid phase and methane phase, all the 3 or 4 stages in a single reactor. Could be multiple stage digester, like allow the stages of anaerobic digestion to happen in separate tanks, like in the example of 2 stage reactor. So, the first 2 steps can occur in a one tank, then the substrate is transferred to the second tank where the methogenesis occur. So, there is possibility that in a there will be a 2 tanks, one tank for the hydrolysis and acid phase, and the other in the same outlet is reaching to the another tank for methane phase or methogenesis stages. So, here this hydrolysis like the same, there will be 2 tanks. The first tank hydrolysis and acidogenesis stage could be possible, and the next stage the methogenesis stage could be possible. The separation of digester is hydrolysis, methogenesis changes the process dynamics of the digester by allowing the individual bacterial species separately and to perform the hydrolysis and methogenesis. 2 stage reactor maintains pH for proper functioning of both hydrolytic acidogenesis and methogenic bacteria at their respective functional pH range. So, you know that this acidogenesis stage, the pH will be always in the acidic condition, and for methogenesis it will be required neutral pH. So, in that case to especially maintain the particular pH for the particular stage, that could possible. And here in the hydrolysis process, if the entire material in the acidic condition also, your hydrolysis will be more faster, could be possible. Now, next is the raw material availability. The gas production should be proportional to the amount of gas material available, like type of material, like CN ratio of raw material should be in the optimum range for the better digestion. If the raw material is a easily digestible one and size of the digester can be reduced proportionally. So, based on that we can design, means the biodegradability of raw material, based on that we can design the volume of the digester also. Size of raw material, the fed material should be cut into a pieces, so that the surface area for the reaction is the maximum, and also to ensure homogeneous flow of the waste slurry. This is also important. And heating requirement. If the digester is situated in the cold areas, sufficient heating arrangement should be provided to keep the digestion temperature within the optimum range, and burying the digester under the ground helps to minimize the temperature fluctuations of the ambient around the digester. So, I think especially in India, where temperature is around 4 degree, 10 degree in December, January months. So, in that condition is good if you bury the digester underground, we can reduce the disadvantages of the temperature in the reactor. Like mixing requirements, so providing a mechanism of mixing the feed inside the digester helps to ensure the easily availability of feed to the bacteria for the reaction. So, mixing ensures a proper slurry flow inside the digester and minimizes scum formation. So, I will not say that is required for all kind of reactor the mixing, but if you mix having the some mixing unit inside the reactor, that obviously that will be more beneficial for flow also, and also the availability of biodegradable matter to the particular bacteria, that for that also is highly beneficial. Now, construction material available, the use of locally available expertise and materials close to the site for the construction of biogas reduce the cost. Fabrication from corrosion resistant materials such as wood, ferro cement, concrete, brick, stone rather than metal may also be reduced caused by extending equipment life. That is why in most of the rural areas in India, this biogas reactor has been constructed by concrete and bricks or stone to increase the equipment life, or the life of entire reactor can go up to 20 years, 25 years, and maintenance also could be easy. And even the cost of these kind of civil materials or construction materials is not very high compared to the metal reactor. So, larger digester required proper maintenance also obviously, and removal of inert materials such as sand, rocks prevents wear on mechanical parts and extend equipment life. So, this again depend upon what kind of feed we are feeding into the reactor or what kind of substrate. So, the substrate has to be cleaned or should not be have the inert material in the substrate, otherwise it will also create problem inside the reactor. Now, there are some successful trials of various waste materials at solid waste laboratory of IIT Guwahati by Waste Management Research Group. Similar way I explained in one of the lecture of composting of different materials has been done. Similarly, the different successful trials had been done in IIT Guwahati, like for food waste, for water hyacinth, Hydrilla verticillata. I think these kind of material highly lignocellulose material, very difficult to degrade so easily, like pulp and paper mill. This is a industrial sludge, is a crop residue like rice straw. These are the terrestrial weed, especially Parthenium histoparesis is very difficult, and these kind of weeds also are a toxic weeds, difficult to utilize for the biogas production. And also the some research has been done on different kind of cattle dung, also compared that the smaller cattle to the bigger cattle. So, based on that how their dungs are beneficial for the biogas production, also compared and found that cow dung is the best cow dung what was found for the degradation process. And also the one design has come out from the IIT Guwahati, they named as an ABBR, anaerobic biphase baffled reactor. So, I think just to explain that, because this was the one patented technology. So, I think you see in the Deenbandhu model there was one partition was given, but here in this case different baffles has been added into the first phase of the reactor, and there are some changes has been done by addition of different baffles in the reactor. So, this is one laboratory studies has been done on 20 liter of reactor, and you see here these are the different inoculum addition like digested sludge and cow dung has been compared and found that cow dung is more beneficial than the digested sludge as an inoculum into the reactor. So, and had started from 14 days HRT and found that 10 days HRT is more beneficial for this reactor. So, what are the advantages of ABBR? Like increase in efficiency of anaerobic digestion and decrease the problem of buffering capacity, which inhibiting the methogenic process, does not affect the process dynamics, low concentration of volatile fatty acids accumulation reaching the methogenesis process, and number of baffles provided increase the travelling length of organic substrate, increasing the contact time between the organic solids and microbes, and enhance the attached growth process, which increases the hydrolysis and acidogenesis process. So, they also studied onto the pilot scale. So, this is 700 liter or 0.7 meter cube of reactor. So, here the 500 liter was for the degradation process and remaining 300 liter was for gas storage. So, it is a fixed dome reactor, and this is the inlet, So, inlet added from the bottom and outlet from the top area. So, only the slurry will come out, and this is the very big reactor. So, this was the fixed one and this was the floating drum reactor. So, this is the floating drum. You will see here, this is the, this much has been rise they found. So, feeding was around 200 to 300 kg per day into 10 meter cube of reactor. Now, when I talk about the substrate addition, so in the 0.7 meter cube they will be able to feed around 20 to 25 kg of food waste in the reactor. So, that is the major benefit. Why? Because the HRT is very high and degradation is very fast, and even the methane production also was around more than 70%. So, you see here biogas production was good and ran up to more than 140 days, and also this floating type of ABBR of capacity 1 meter cube has been installed under the Govardhan project in Aizawl, Mizoram. So, the small unit, and this was specially for the piggery waste, and you know in the northeast India the major cattle are pig. So, and here we get more amount of piggery waste compared to the cow waste or cow dung. So, and this was one successful unit has been installed. Now, for Indian scenario, there are different kind of waste and different reactors. So, there are different kind of waste, means animal manure like cow dung, poultry litter, or even I was talking about piggery waste in northeast, agriculture residue and various type of agriculture residue, industrial byproduct, MSW, especially food waste or vegetable waste possible to utilize for the biogas production. And types of biogas plants, like this is household biogas plant. This is the Deenbandhu model, same KVIC based floating dome. This is community based biogas plant, capacity of 20 to 1000 meter cube per day, and commonly used technology could be based on KVIC also, and even BARC also they come up with one technology called Nisarguna, where they are maintaining the more higher thermophilic temperature operation of the reactor, are able to produce more methane gas. And I was talking about decentralized composting is more beneficial compared to the centralized composting facility, and in that case also the rotary drum composting is more beneficial if you talk about decentralized composting facilities. Similar way, these kind of community based biogas plant is very important for the decentralized containerized solution could be possible. If you are not going for composting, we can go for biogas production. This is the large scale biogas plant of capacity more than 2500 meter cube per day. It is a very large units, and other technologies could be CSTR, USB. These are all technology for sewage treatment also is available. This is very popular, and if you want to read, you read more onto CSTR, USB. So, these are the different technologies are available, and few commercial digesters available in India, where the HRT goes to 25 to 30 days. This is the one very well known company in especially in Kerala, in South India, where this is a Biotech Limited. They come up with this Biotech reactor. The flexi balloon biogas plant. You can see there is the one person name, and this is the Syntex reactor. This is also very popular in India. This is Aarti biogas, this is also FERT reactors, and this is biogreen solution. So, it is all kind of reactor. If you see the biotech to Aarti to biogreen and Syntex is almost similar kind of reactor. Okay. So, almost all the reactors are floating dome reactor, okay, and the almost size is 1 meter cube of all the reactors. But only problem is that HRT is 25 to 30 days. But if you compare that reactor of designed by IIT Guwahati, that ABBR, where HRT is only 10 days, means the same kind of reactor of Syntex or Biotech, in a 1 meter cube of reactor you will be able to feed only 2 kg or 5 kg of waste material in a day. But in ABBR you will be able to feed 20 kg or 25 kg of waste material. So, for community biogas units, the ABBR is more acceptable, and this kind of reactor you will be able to install at household level only. And if you see the status of small scale biogas plants, small scale means the size less than 2 meter cube per day in India, and along with that the yearly installation. So, you see the numbers in millions, these are the cumulative numbers, 4.55 millions of biogas plants, and yearly installation you see that now it has been reduced. Earlier was a large number, now in 2017 only 36. I think is again depend upon how much data are available or how much data is documented. This was we got it from Indian Biogas Association, this data. And for major biogas plants in India, like in Lucknow for MSW 300 metric tons and producing 5 megawatt energy. This Chennai vegetable waste 30 metric tons, able to produce 230 kilowatt energy or electricity. And this is Vijayawada vegetable waste 16 metric ton, which able to produce 145 kilowatt electricity. And Ludhiana, this is specially for the animal waste and produce around 1 megawatt energy. This is the status of grid connected biogas plants, okay, and the size is more than 250 kilowatt in India, and the cumulative you see the number of biogas plants are now is around 152, and yearly installed in electrical capacity like now is up to 223 megawatt energy is connected to the grid, and this is one which is off grid electric generation, means I think this is not connected with the grid. That numbers is also very large, like around 260 biogas plants are available, size less than 250 kilowatt, and yearly installation also is 5.5 megawatt electricity production. Now, if you see the timeline of policies showing various initiatives taken by the Indian government in last 30 years to boost the waste to energy and biogas reactor. This is also one important point when you talk about waste to energy. Please do not only thought about incineration process. This is also waste to energy production. So, here the waste to energy means the same gas could be used for the cooking purpose also, that is a one kind of energy, and also same gas can be possible to convert in the electricity, the same methane gas. So, this is also one kind of energy is production. So, in 1981 the first national program for biogas development was launched, and ownership of 2 to 3 cattle is one of the criteria to gain the subsidies provided under the program. So, even the farmers which were having 2 to 3 cattles with them, they used to get it 5,000 rupees subsidy, or even I saw in some of the states. I visited one few locations in Nagaland state, where the local authority are providing rupees 5,000 rupees for construction of 1 meter cube biogas reactor. So, that was one program has been come up. In 1995, National Program to Recover Energy from Municipal Solid Industrial Agriculture Waste was launched, and 2006 an off-grid biogas power generation program was initiated by Ministry of Renewable Energy. In 2006, to promote decentralized power stations in the rural areas like 3 kilowatt to 250 kilowatt energy, and financial incentives are offered to private public players for setting up a biogas power or co-generation plants, as well as production of bio CNG using biomethanation technology. So, in that also there are number of off-grid biogas power generation plants has been installed. Size was small, like is less than 250 kilowatt electricity production or power production. So, in 2016 the rules regarding management handling of solid waste first notified in 2000, and that has been revised in 2016, and central government released a new tariff policy that made it mandatory for electricity distribution company to procure 100% electricity generated from waste to energy plant. So, this is I think one very important document has been come up now. So, for electricity distribution company, they can procure 100% electricity, whatever is generated from waste to energy plants, they can collect it and they can distribute to the local residents. So, now who are the Indian stakeholders for biogas? So, whatever the policy has been made by center, especially MNRE, Ministry of Renewable Energy, and even some more ministries also, they come up with different policies, like Ministry of Science and Technology. They also provided some funding for the different projects on biogas production. From the state, like example was Nagaland, they also promote. Some municipal bodies also they come up with different biogas units, and academics, like I was talking about research organization like IIT Guwahati, they have 10 meter cube of reactor. Even you see in IIT Delhi, there is a one center in rural development, they also have big biogas units in their campus also, and also installed in some local areas, in the some local rural areas. Similarly, in the some universities, some training institutes, and financing could be from banks, some subsidies, some funds, and some other innovative instruments can be come up the financing, and economy wise it is beneficial to the farmers, some companies, some associations, and some standard bodies. And finally, who are the beneficiaries? The beneficiaries was NGO, public and social entities are beneficial from biogas projects. So, challenges faced by biogas industries in India and their mitigations. If you see the challenges, one was the social stigma, like NIMBY syndrome was in India. This is not only for the biogas one, but also for composting. NIMBY means not in my backyard, because obviously is this both the technology, like whether is a composting or biogas techniques, is dealt with organic waste. Organic waste means there will be a odor issue, handling issue will be somewhat different than the other ways, and market for organic manure is missing. This is also, I think I talked about composting also. I think because already the commercial fertilizers are available, so why somebody will purchase the compost. Similarly, we have different ways of electricity production, so why somebody will try to produce biogas out of that. So, I can think about the rural areas, because maybe if such areas is not available, the cooking gas is not available in the local area, or 24-hour electricity is not available. In that case, they can accept. There could be some market is possible, but again the both I can say that I do not say that you will be required proper skill to run those things, but for anaerobic digester you should be well aware about of feed and the operation conditions. You need to be well aware, and some issues will come up also. You need to know that how the maintenance or repairment of the reactor could be possible. That kind of skills are required, and feedstock security, supply chain, availability of skilled manpower, even waste supply also is not proper non-segregated material. Even the higher capital cost, if somebody wants to have the very big units, so you will be required large capital cost, and the insecurity of the business and the lack of credibility of customer. This is also one of the risk is include into the biogas units. So, likewise these are some challenges, but there are some mitigations also you can find, like for NIMBY syndrome, or there is no market. So, you need to promote awareness more, and why not you include the some NGOs which can work for local authorities, like for municipal board or state, even for center. These NGOs can work for the awareness process, and even they also can work for collaboration with the academic institute, because there are number of academic institutes are working, like I was sharing about IIT Guwahati or IIT Delhi are working onto the very the 10 meter cube, 20 meter cube of biogas reactor is very difficult in the academic research institute. If such kind of reactor is able to run at academic institute, obviously the same experience can be shared into the other part, the other area, or into the field in the bigger scale could be possible. So, and these academics also, they are the skilled people, they know more operation things, can easily share to the local people. And also like waste means, I think if you talked about new MSW rule 2016 already targeted for segregation of waste. So, your biological waste or wet waste segregated material, if you are able to get, you can easily change the supply chain. And also market, industrial market can be created, and likewise there are the challenges. See, challenges could be for any kind of treatment facilities could be, but there will be some mitigations. And when you talk about the centralized facility, obviously you have to depend upon the proper policies, and for local authority you will be required lot of help will be required from them. But if you talk about the small units or decentralized facility, like in the apartment. So, apartment you need not to take help from the local authority. So, this is your apartment, their segregation could be easily possible. There are whatever the residents are available, maybe 20 families or 25 family, you will be able to aware them very easily. by showing that how once this waste is not segregated and once it is reaching to landfill, what could be the problem. So people will be more aware in the small community and can have the small reactor in that particular apartment, and whatever gas is producing, that gas could be utilized for the cooking purpose, or can be shared to the every residence into that particular apartment, or for electricity production also could be possible. Only the problem will be the capital cost has to be shared, but see, these kind of facility can be run for 20 years, and suppose capital cost can go up to 5 lakhs rupees also, or 5 lakhs or 10 lakhs rupees. So, 20-25 families easily can put that much amount of fund, can raise that much amount of fund to have such kind of facility. If suppose local authority will give some subsidy to the such kind of apartment, maybe 50% subsidy also, if the local authority or local corporation will give it to the such kind of apartment people, that is highly beneficial and can easily possible to install such reactors into the such localities. So, by that way I think we can promote the biogas units into the residential areas. Now, we will see the one or two case studies in India. So, this is a high rate biomethanation plant, is a 1 megawatt electricity production plant in Punjab, India. So, this is a one reactor has been designed by Intec, Austria. So, is commissioned in year 2004. This plant is located in Ludhiana, Punjab. Feedstock is a cattle manure fed at the rate of 200 metric tons per day, means is a very big unit. Now, waste is collected manually from the local Gaushala and feed it into the reactor. Intermediately steered tank reactor. So, is a ISTR based on the biogas induced mixing arrangement. So, intermediate steered tank reactor means the mixing unit is available in the reactor, but is a intermittent. The gas storage is 1000 meter cube bell and shell type made of local nylon fabric, and digester volume is 2 into 5000 meter cube, means 2 units of each of 5000 meter cube, and end usage is a power generation. Okay. Now, this is another biogas plant or 14,000 meter cube in Gujarat, India. So, this is owner is Bharat Biogas Energy Limited. So, is commissioned in year 2014. This plant is located in the rural area in Umret, Vadodara, Gujarat. Feedstock are animal dung, discarded potatoes, pulp and press mud from nearby local industries, and CSTR based biogas plant having upgradation facility along with CNG filling stations. CSTR means continuously steered tank reactor. So, continuously the feed is steered into the reactor and along with the CNG filling stations. So, digester volume is 2 into 6000 meter cube. So, is also 2 units each of 6000 meter cube, and end usage is bio CNG for industrial use. And digested is processed and conditioned as fertilizer with defined nutrients and sold to the market. So, the whatever the digested also is coming. So, this is the digested one from this is the both reactor is the digested, the outlet is properly dried and selling to the market. This is another study, it is a decentralized biogas to power projects around 25 kilowatt in Maharashtra. So, commissioned in year 2009, this plant is located in the urban locality in Pune, Maharashtra. Feedstock is segregated organic from MSW, fed at the rate of 5 tons per day. and waste is collected by Pune Municipal Corporation from nearby establishments such as vegetable markets, hotels or colonies, and two-stage digestion with aeration and leachate recirculation facility. So, the two-stage process means in the first reactor the aeration is provided for the hydrolysis process, and leachate recirculation facility means whatever the digestate are coming out, that is again replaced into the biogas reactor. The reactor have the gas storage of 275 meter cube each in neoprene rubber with explosion. The gas storage 275 meter cube tanks are available for the gas storage. Digestate volume is 200 meter cube, and end uses is illumination of street lights, and digestate used as organic manure for horticulture purpose. So, this is for specially for MSW. So, now here today we saw that there are different reactor started from 1936 the Chinese reactor, and again 1956 of Janta model by Mr. Patel, and now there are different kind of reactor, different scale of reactors are available, but I am seeing that the HRT is very high in the most of the reactor, that HRT goes to 25 to 30 days. Again I think the substrate, if it is agriculture based reactor, in that case your HRT is again go for more than 25-30 days. So, in that case you will be required large size of reactor. Now, still I think in India research is required to reduce the HRT, means we have to again modify the reactor like what reactor has been modified by IIT Guwahati. So, similar way there is more research and not only the research, but the operation onto that such kind of scale is important to know that, because some factors is not possible to resolve at the small scale like the climatic conditions, availability of the substrate, the mixing facilities, grinding facility, pre-treatment facility or the production of digestate, and again the management of digestate is not possible to work onto the small scale unit like 1 meter cube or even 10 meter cube facility. You need to have the experience onto the larger capacity and also for production of bio CNG or electricity production. For that you need lot of research. So, I believe that the collaboration of local authorities like corporation or state to the academic institutes could possible to go for this kind of research or at higher level, and I believe that in India this either composting or biogas is important. Without that entire solid waste management could not be possible. Whether you installed incineration facility or design proper landfill, you need to have proper biological treatment facilities. So, I believe that you people have understood completely the biological transformation process starting from composting to the anaerodization process. Now, the remain portion is a landfill. So, the waste is not incinerable, not biological treatable, will goes to the landfill site, and from next class I will talk about landfill design and their operation. Thank you.